So to start with, was just to give you a recap around what we are talking about. We are talking about why identities were needed. So there are two reasons the identities were needed. One for accounts, and other for nodes, and any other kind of uh, identities which may be very much specific in permission network. So that is where we were talking about authorized identities. When we talk about account, what are basically account? Account are basically, so you as a user who is holding any value, an external user who may not be directly holding a node, who may be just an external user who is coming and interacting with the blockchain network via interacting with node, and he may not be a node owner. So those are accounts. Nodes accounts are very much required in order to distribute certain kind of incentive, as well as more than that, since whatever gets recorded in the ledger, whatever gets published in the ledger, validated in the ledger, needs to have an identity associated with it, that who is writing, who is doing what. So that is where node also needs to have an identity. We talked about self-sovereign identities. Self-sovereign identities are kind of mainly used in public blockchain space, where it means that it is not controlled by anyone. It is not controlled by a third party. You yourself as a user can go and create an identity for yourself, which will be recognized by the blockchain protocols. So these kind of identities are known as sovereign identities or self-signed identities, to be more generic and to be more not going into specifics. But when we comes to permission blockchain, that is where authorized identities are required. Because by default, permission blockchain means there is certain layer of permissioning, there is certain layer of trust already there, and each and every node does not have same amount of power. Each and every node does not have same amount of uh, say in the system. So that is where authorized identities come into picture. So any question around this quick recap? We'll just give 2-3 minutes. If anybody has any question, we'll quickly cover it and we'll move on. Okay. So authorized identities, what it means basically, that we are now looking into the purview of, or we are looking into the ecosystem of permission blockchain. In permission blockchain, just try to conceive in today that every node may not have full view, every node may not have same power. Different nodes in permission blockchain are required for different purpose, for different kind of act. That is where also, and one other fact is that these permission blockchain, the companies or the network of companies which are launching it will not allow a sovereign identity, because they may have their own identity system in place. That own identity system in place can be as simple as an Office 365 account. That identity can be as simple as a G Suite account. So what they do, they say that here the identities are controlled by certificate authorities. Certificate authorities are the authorities which are running in a distributed fashion or maybe under a decentralized fashion. But these particular nodes have very specific purpose. These particular nodes have very specific task to be taken in this particular network. So they only issue identities. Now, how those cluster can run? It can run in a decentralized fashion. It can run in a non-decentralized fashion, in a centralized fashion, but in a distributed fashion. So that is for up to the network participants to decide. But at the very core, there is a certificate authority which issues certificate to the accounts, to the nodes in a permission fashion. That certificate has all those requisite data payloads or data to identify which kind of user it is, what kind of permission he has, and whatever they are doing, they need to sign those transaction payload or their action with those certificates. And again, at the validation layer, again, the validation happens whether the person who has signed it does have the right authority to perform these tasks. Also in enterprise scenario, right, it very much matters that identity do expire. because various stakeholders who are working in that network may leave the organization, or few people. So password rotation and these kind of things are very much important within the organization as such also, right? So that is why these CA also offer a very strict control around expiry of identities, so that how identities can expire. It also provides control to the network administrator or the people who are governing that network to revoke accesses. Same thing cannot be done in case of a self-sovereign identity system, or you cannot go and just revoke somebody's access on a Bitcoin layer if he is accessing through his identity on a protocol layer 1 of Bitcoin. But same is not applicable in case of a Hyperledger Fabric or any permission blockchain network. CA do has authority to revoke identity, which they think that it should be revoked, banned, or all those stuff. What are digital signatures? So ultimately, these identities, when I say right, they require to sign something. So that's where digital signature comes into picture. So again, it's a very generic terminology. When we will start looking into blockchain in very much detail, we may not encounter digital signature as a terminology too often. It is more something which is more applicable to your normal day-to-day IT operations. But when it comes to blockchain, still we have kept it because in order to just explain in a more generic fashion. So digital signature can be used by both sovereign and authority-based identity. Information sent to the networks, proposed transaction to be digitally signed by the identity. It's nothing but what the same proposition which I have been telling in the throughout the lecture today, that whatever you do, identity need to sign it in a such a way that so when the signing happens, it's kind of a binding happens, right? So it may not happen. So when you sign a transaction, nobody can take that transaction, remove your signing and put his signing in place. So when a transaction is signed, it is binded to an identity. A hack in between or a middleman hack cannot happen where they take out the transaction, they decipher, okay, they remove the signature, they take only the payload. So those things are not possible. That's how these signing happens. And we will also understand more better when we will be creating signed transaction over a public blockchain network or a test network. And for authorized, it will be require a certificate. So certificate before signing, it will require to check whether it is expired or not, or certificate has not been revoked. So all those things will happen. Whenever these transactions are put, every node who is going to validate it are going to mathematically validate the signature to say that, okay, no impersonation is happening, whether the right person in case of authorized blockchain or a permission blockchain, if a right person is putting in transaction or not. So this is all related to identities. Any question? Any doubt? And I will be trying to go a little fast today because as I have already told, right, we will be trying to end the sessions before 7:15 or 7:10. So in case you all feel that I need to slow down, just let me know. But by default, I will be taking on sessions a little fast in comparison to the first session we had. Okay, in case no question, let's move on to transactions. So in a very first lecture, we did talk about, right, anything on the blockchain network is a kind of transaction. At a very core, understand anything which is getting added into the ledger where you are doing a ledger entry is a transaction. So any request to add data onto the network, any request to add data on the ledger will be considered as transaction. So at a very simple level or a very generic level, me transferring certain value to somebody on a blockchain network is also a transaction. So at a very core, what it is, me telling that insert a data which says that I have transferred this amount from my account to somebody else's account. So that is what data meaning, like can send money, one cryptocurrency unit is a transaction. In order to do so, if Ken is sending something to somebody else, he will firstly he will require to prepare that payload. When I say payload, what it means that he will require to prepare a transaction which will say that he wants to transfer this amount from his account to some another account. Then he will require to sign this transaction. Sign this transaction through what? as we already talked about, in a sovereign identity basis, there will be generally two keys. One is a public key, another is a private key. Public key is the key through which world recognizes you. Private key is something which is private to you and through which you can prove your identity. So if he has to say that I want to transfer this amount from my account to somebody else's account, he will require to first sign that transaction, sign with transaction with his private key, which has those value in the account. Now, once the transaction has been signed, he will send these transactions to a node, a blockchain node, because that is how he can communicate to a blockchain network. In order to communicate to a blockchain network, he will require to connect to one or many node in the blockchain network. Without connecting to a node in blockchain network, he won't be able to communicate to a blockchain. But he can prepare transactions without connecting to the blockchain node, because as we will delve deeper, there is way a transaction needs to be prepared. It can be prepared offline. It has set of data structure. It has set of protocol which you need to follow. And these signing all can happen offline. But in order for these transactions to materialize, it is required that he needs to put this transaction onto the blockchain network. Only way to put in the blockchain network is to connect with one of the node, which is within that particular blockchain network. So he will find one. So there are two ways. Either he spin his own node and connect to a blockchain network, or he finds a node, he finds a service provider which is running a node, who is accepting transactions to be put in blockchain network, who is validating transactions. So there are two ways. Either you go and spin your own node. For public blockchain node, you can spin your own node. You can get attached to the network. It will require you to incur a constant cost, or you find a service provider who is doing this. You connect with them. You either connect to them via API or you connect to them via RPC protocol. So whatever are the protocol layers which are exposed, you connect to them, you put in your transaction, the node will validate those transactions, node will validate Ken's private key, node will validate whether the transaction structure is correct or not. And if it is correct, it will broadcast it to all other nodes within the network that this particular transaction has come. And in case common consensus comes to an conclusion, the transaction will be included into the blockchain ledger. Any question here? Any doubt? Okay, there is a question: does permission blockchain not violate the idea of decentralization itself? So see, decentralization may not be necessarily required everywhere, right? Firstly, why a permission ledger is getting used in enterprise? It is not that everybody in enterprise want decentralization, right? Not every business idea needs to be decentralized in nature. Correct? There are business ideas which require to work under certain fashion. So depending upon what kind of business idea is, there can be a permission network where permissioning is there. So yes, it does not totally prescribe to all idea of fully decentralization, but what it takes all the important ingredients from existing blockchain, public blockchain, and put the programming construct on top of it, which allows businesses to take advantage of blockchain technology for their business. As I have told in very first session, right? Why businesses are looking for blockchain if they do not want to go decentralized, if they do not want to go totally decentralized. The reason is any business can only prosper if they are able to collaborate with other businesses. Now, these other businesses in general, when they collaborate, there is a little bit amount of trust which is already there. What they lack the tool set to seamlessly collaborate and seamlessly exchange information. So that is where blockchain comes into picture and provide them a business network. So till now, when you talk about blockchain network in public construct, you do not talk about business network as such. You talk about a network in which public is transacting, a value chain is getting maintained. When we talk about blockchain in an enterprise or blockchain in a business, we talk about a business network. So by default, a business network, there will be different stakeholders with different say in that particular business. That's how a business runs. Everybody in a business domain does not do everything. So from that particular construct and that particular perspective, it makes sense to use permission blockchain for enterprise or businesses, or to go even further, use blockchain for the use case, how it can be constructed. Do not try to put the same pattern that this is how the public blockchain works, this is how the blockchain works in ideal state, and start putting same template on the businesses. It should be businesses who are trying to take advantage of the technology in order to conduct their business in a more better fashion. So that is the construct and that is the way. So the statement itself is right, but if it should be taken with certain context, that why even businesses are using private blockchain or a permission blockchain, right? It is not that they are only looking for decentralization. It is more to do with, it is something more than and more and beyond decentralization. So I will skip this slide. We will take it probably during our session when we are doing it hands-on. We'll take this particular context then. Anything related to transaction? Any question around transaction? Any doubt around transaction? Any question? What is meant by transaction? What can be called transaction? What cannot be called transaction? Reading something from the ledger is not a transaction. Try to understand. You are reading something, you're not trying to put something into the ledger. Anything which is going to get recorded is a transaction by default. So any interaction, your interaction with the network, which is leading to insertion of a record, should be considered as transaction. So I was using a term payload, transaction, and all these things. So see, everything has a structure to it. Now, question is why that structure needs to be there. So at the very first thing, everything in blockchain, whether you talk about block, whether you talk about transaction, whether you talk about payload in the transaction, whether you talk about public private key, which is getting prepared, everything has a data structure to it. Everything has way of keeping information and putting information. Why? Because that optimization is required, right? You need to bring in certain standardization around how people are sending data, how nodes are able to comprehend that data, and how those data are put into the network. So that is one of the very first basic reason why there should be a data structure in all the things which we are talking about. Other thing is that we need to have something which is most optimum or most efficient, because ultimately whatever is going to get recorded needs to travel across. So there is a very big networking, or at a network layer, there is going to be a very heavy data traffic if we are not coming up with a efficient data structure that how these data needs to be stored. And it all started with Bitcoin. At that particular time, we did not have the same bandwidth of internet what we are currently having. So that is also certain of the reasons why Bitcoin has been written or it behaves in that particular fashion. And similarly, as the technology has progressed across the blockchain, we'll see a marked difference around how other blockchains have approached, whether public or permission blockchain has approached the same protocol in a different fashion. Underlying principles remains the same, but the way the approach, there have been new construct or new algorithms and data structure which has come in later part of the development. So it is very essential that these data structure at the time when the blockchain protocols were written for efficiency, and they follow certain common standards. So everybody who is interacting with blockchain actually put the payload, signs the transaction in similar fashion. Otherwise, it will be all chaos. You will never be able to build a software which is able to identify, which is able to recognize these things in that particular fashion. So it has gone, the next slide has gone into more detail. Why is a special data structure needed? So again, the underlying theme is same, because one of the very important factors is, again, you need to build a data structure which is less taxing, more efficient, able to convey maximum information with least amount of data storage, because these all will be stored across the network. These all will be stored across various countries at various locations. You want entry of barrier to be very small, right? So these are certain things that needs to be taken in consideration while preparing these data structure. Even in fact, when you talk about blockchain, the blockchain name even in fact comes from the how these data are stored. I think we have not covered it now, but I think this is not the right time to go into why block and chain and how those blocks are there. So let's say we have to store certain transactions. Now, one of the way would be keep storing the transaction as they come, keep broadcasting the transaction as they come. So in real time, a transaction has come, it gets recorded in the real time. And when I say recorded in the real time, at the same time, it should undergo the consensus mechanism. Everybody in the network should have recognized it. Everybody in the network should have validated it and put it in their local ledger. Because if within the blockchain network, these data are nothing but synchronized local copy, correct? So if you go to any node, you are able to see and perceive same data. So one of the efficient way was to actually take certain transactions, bunch them together, put it in a block, and link this block to preceding block. And the next block which gets created is also linked to this particular block. So it was very much similar to how you record information in your notebook. So if you open a notebook, it will have a page numbers 1, 2, 3, 4, 5. Then you will have various lines. Within a page, there will be a set number of line that in this page, if we are talking about ruled copies, right, a rule notebook, there can be a 40 line or 30 line, but a set number of line. Every page will have same number of line. There will be a sequence of page numbers. So what it says that, okay, whatever has been written in a page solidifies when you have written the last line and you move on to the next page. So in a similar fashion, these block can also be perceived. That each blocks allow a certain number of records to be written. When those records are written, it requires to come under consensus that these transactions are correct. These blocks can be written onto the network. So firstly, they write on their local copy, on their local storage, and they broadcast it throughout all the node that you also kindly put this particular block on your local storage so that everybody is in sync. Any question here? Because the next on things which we are going to discuss are going to be more complex. So let me, if you have any questions around only what the data structure, transactions, and the identities are. For the next few things, we will discuss about how the blocks formation happens, what is hashing.
We have a question, Ajay.
Yeah, go ahead. Okay, we have an open question. See, transaction is only supposed to be done when it is written all across the node. It is not that when it is written in a local copy. So if it is only getting written in a local copy, it doesn't mean that it is written on the blockchain. a transaction will be considered done when the transaction is written in more than 50% of the nodes which are running in blockchain network. And that is where also generally when somebody do a transaction, it is recommended to wait for some n number of blocks or for n number of minutes in order to assume that the transaction has been totally accepted. Any other question? So for Bitcoin, recommended time is 10 minutes. For Ethereum, recommended times is 6 block. 6 block, it will be 90 seconds. That is 1 minute 30 seconds, so 1.5 minute. For Bitcoin, it is 10 minutes. For Ethereum, it is 1.5 minute. For permission ledger, there is no recommendation as such, because once the block is submitted, there is just given amount of nodes which are processing it. So it is just the block minting time. So for Hyperledger Fabric, you can set it as customized as you want, as low as 1 second. And depending upon different private blockchain, it can happen in that particular fashion. So within DLT Labs, we run one private Ethereum network where the block time is 5 seconds. The minting block time is 5 seconds. It can be even reduced to 2 seconds given the amount of decentralization and distribution we have. And for that, we take confirmation for minting of 2 blocks. So generally, in that particular network, 10 seconds is the recommended time that you can assume that this transaction has been written, or it is confirmed. It cannot be reverted back. Any other question? I will also explain why we say for Bitcoin it is 10 minutes and why for Ethereum we say why these recommendations are there. So we will try to cover it in today's session. There is a mathematical model which recommends that there are mathematics, probability and mathematics associated with it. Everything in blockchain is probabilistic. So that is where you will say there is eventual consistency that, okay, eventually this particular transaction will materialize. So if from a philosophical point of view, you want an answer that when a transaction can be considered as confirmed. So philosophical answer is in a blockchain network, never in a public blockchain network. But with probability in place, with mathematics in place, those numbers are there. Okay, in case no other question, we'll move forward. So see, as I told, right, either it can be real-time transaction getting committed across the block, or it can be done. We use Merkle tree. We will not go in detail in Merkle tree today, but we are talking about data structure in general. So just for your answer, the answer is Merkle tree. We will delve deeper into how the Merkle tree is and how that Merkle tree data structure is during one of our hands-on sessions, or when we go much deeper into the technology segment. So try to understand first what we have not covered up till now. We have been talking blockchain in a very generic fashion, but now whenever from now onwards we're talking blockchain, we will always talk with a segregation, whether we are talking for a public blockchain or we are talking for a permission blockchain. These discussions are very much interesting in a public blockchain domain, what we are now going to have. It does not have very much impact in a permission blockchain space. So in blockchain, we all started with, right, that it is decentralized in case of public blockchain. In order to maintain that decentralization, everybody will require to, firstly, decentralization or distributed of data need to have a node with them, correct? And if somebody is running a node, he is spending money there, correct? Either electricity or his RAM, CPU, there is certain cost going on. Storage cost also is going on. So why somebody will do that? Why you will decide that I want to run a blockchain node. It cannot be simple because you believe in democratic value of what blockchain is bringing in, because that is not going to put food on anybody's stomach who is running the node. He's going to spend money, and people do spend a lot of money in running these blockchain node currently, especially for Bitcoin, given amount of power for the consensus which it requires. So first question is why somebody will do that. So the inventors of blockchain, when they invented it, the group of people or a single people, whoever we assume Satoshi could be, they came up with a concept of incentivization. They told that, or it was proposed, the network should incentivize honest people in such a way that they are not required to do honesty in order to get value from the system. Or if anybody try to gamify the system, ultimately he should lead to loss making at a very core protocol layer. So it was come to a consensus with the developer community that we should start batching transactions in a block, and instead of confirming a single transaction, we should confirm a block of transaction. And whoever is successfully able to propose the final block and gets accepted should be incentivized, should be given the native token or the native cryptocurrency on which the blockchain is running. So what it means in case of a Bitcoin is somebody is creating a block, minting a block, proposing a block, and it is getting accepted, he should get certain Bitcoin for its effort. And this incentive will actually allow people to come and run node. Now the other proposition was, if it is all about capturing transaction, it's all about proposing block, there will be a lot of competition and everybody will be competing at the same level. So there needs to be put in certain randomness that who can propose and whose block will be accepted. So they came with a proposal that we will use a concept known as proof of work. So whoever is going to propose a block, whoever is going to mint a block, whose block will be finally accepted, need to show the proof that he's working. And what that work is, they told that apart from bunching these transactions together and clubbing in a block and writing into the local copy and sending out to all the nodes, with that, they will also require to solve a puzzle. And that puzzle answer needs to be embedded in that particular block. So when it reaches to all the people can verify whether he has solved the puzzle or not. And puzzle will be in such a way that if you know the answer, you can easily verify. Everybody, if I propose an answer that this is the answer of the puzzle, everybody without doing a humongous computation will able to come to a conclusion whether this answer is right or wrong. In order to come to an answer, you need to do a lot of calculation. But if you have a number and you just want to check whether it's the right answer or not, you are not required to do a lot of calculation. It will be very instant at that particular instant. So everybody who is going to propose a node, who is going to bunch these transactions, call it a block, write in the local copy, also needs to solve the puzzle and put the answer of that puzzle into the block payload or the block data before broadcasting it to everybody onto the network. And when everybody receives those, they will validate few things. One, whether he has solved the puzzle correctly or not. Second, they will also validate all the transactions which are there in block, whether these transactions are not malicious, they are not manipulated, they are signed by the right key, their payloads are correct. And if they find everything good, they will commit into their local copy. And when majority of the people have committed into their local copy, the block will be materialized as a block in the chain. Also, it needs to be linked to the previous block. Correct. So that is also needs to be there. So when somebody is building a new block, it needs to take certain piece from the previous block, put it onto the new block so that it can be changed. So there can be a chaining. It is similar to linked list, but not exactly similar. So if you are having trying visualizing it, just consider for now, from today, just consider it as a linked list. But in future, when we'll be having a certain hands-on exercise about creating a block, committing a block, we will have better understanding how these things happen. Any question here? Any question around incentivization, puzzle, proof of work?
So Ajay, Mac here. So regarding the incentivization, so we understand, like, for Ethereum, it's gas, and Bitcoin, it's something else. For most of the carbon-free, or else, carbon footprint-free blockchains like Solana, how does the incentivization works there? Why? Because the consumption, power consumptions, and everything, and how the community gets benefited is a question I have.
Okay, so firstly, Ethereum incentivization is not gas. So gas, they mainly look from transaction perspective and when the transactions are put in. For Ethereum, the incentivization is in native currency Ether only. Gas is the unit which is used to calculate the amount of compute power which will require to validate a transaction or write a transaction. So those two are different things. In any case, just to answer you, it is not the same. So the incentivization happens in native Ether. What is gas and what is gas price will come later when we are talking about Ethereum. So as every blockchain progressed, Mac, every blockchain has come up with its own incentivization mechanism. Okay. So for Bitcoin, it was proof of work. For Ethereum also, it was proof of work. We are moving towards proof of stake. Similarly, whether it's Solana or whether it's other layer 2 protocol who are trying to bring in people and trying to decentralize the network, they have also kept in different type of incentivization mechanism. Incentivization mechanism in Bitcoin and Ethereum is a bit dynamic in nature because it takes in consideration of what the network load is, what network throughput is happening, and it keeps on varying with. So there are a lot of protocol and policies around how these incentivization will change and the dynamic nature will change. Proof of stake is something which Ethereum is moving towards in order to do two things, in order to bring in more scalability into the system, and otherwise in order to offload the cost which miners currently are incurring.
Got it. We have two more questions. Yeah.
So Raghunathan, Bitcoin does not, Bitcoin already has a proposition where incentives will not be given forever. There is a time when the incentives will become zero. So there are two types of incentives with a miner get. One is just writing a block, another is getting the transaction fees. So whatever transactions are clubbed in. So okay, so for just consider, no, it depends on blockchain to blockchain. Every blockchain does not say that incentive will be given forever. What is proof of concept? I also do not know what is proof of concept. Is there a new consensus mechanism I will require to read? There are proof of work, proof of stake, proof of elapsed time, but I have yet to hear, or probably it is there. I'm yet to read what is proof of concept. So if you can be more elaborate with what you want to ask, I can give you answer. Whether it's a general statement around proof consensus mechanism or it is what you are asking, I'm not able to get it. Yeah, please elaborate more.
Might be that the same proof of work, proof of concept, which we go with the product development, it seems.
Okay. Data structure what we use in blockchain, I think I have answered. It is a Merkle tree. We'll get more details later. Any other question, guys?
Yeah. one question we got up. What data structure we use in blockchain?
Yeah, that I told, right? We use Merkle tree, and
Okay.
we'll go deeper in Merkle tree in certain on the hands-on exercises and certain exercises when we are looking into Ethereum blockchain in detail.
Okay. I think we're good. I don't see any questions.
Okay, so
Just a second, Ajay. One more question. I see one more question.
yeah, Harshit, so I will let you know. So there are two aspects of incentivization. One we have talked, one we have not talked about. So I will explain that in later. Also, there is a lot of behavioral economics which actually also comes into picture. So as we talked about, right? So let me explain this thing in more detail about the incentivization. So there are two type of things. One we talked about, or one we have already talked about, that miner will get certain incentive for putting the block onto the blockchain, right? For solving the puzzle properly. Other important aspect is many of these private blockchain has a concept of transaction fees. So whenever a person is going to put in transaction, let's say I am proposing a transaction where I have to send this amount of something cryptocurrency from my account to some other account, I will also add a fee to it. Why I will add a fee? Because in order to, let's say it's a public system, right? Everybody is trying to put in their transaction. And as we talked, right, there are certain rules. So every page can have limited number of records. Similarly, every block can have limited number of records. And everybody wants their transaction to be put in blockchain at a faster pace. So they put a certain fee to it, which directly goes to the miner. So if miner sees that this particular transaction is giving me more fees in comparison to other transaction, he will include that transaction earlier, or he will try to include that transaction in the next block as much as possible, because he is going to get another incentive out of it. So there are two incentives when a miner writes a block into a blockchain. One is writing the block, proof of work incentive, which is fixed under certain mathematical rule, under certain amount of blocks, right, which changes dynamically in that certain rules as the blocks are mined. So that is a static component for some forecasted amount of block. So that goes to him. Plus, whatever transactions he have committed, summation of all transaction fees also goes to the miner. And the proposition where Bitcoin says that mining fees will be made redundant in future. So they have a concept, they keep on reducing mining fees, they keep on halving it. It's a geometric series where they keep it halving it after every 4 years. So what is going to happen? There will be a time when these halving will lead to near value zero. Correct. And they say that due to behavioral economics, till that point of time, the value of Bitcoin would have become very much that these transaction fees itself would be sustainable for miner to accept and keep on committing the transaction. Now the question is, why to make it zero, right? Why not make it always? Bitcoin has an upper cap around how much Bitcoin can be there into a system, can be there in the system, how much Bitcoin can be minted. So it is not that for eternity Bitcoin can be minted. So there is an upper cap, there is a number which says that only this much Bitcoin can be the maximum there into the system. And there is only one way Bitcoin is minted, is by miner getting a mining fees. There is no other way in a system a Bitcoin is produced. For transaction, you can only transfer Bitcoins which you have. Mining fees is the only thing which gets minted out of air. it gets introduced. It is like mining and finding gold. So that is where the mining also comes. So you mine, you do certain work, you provide proof of work. In case of a gold, when you have mined, the proof of work is you getting a gold at the end. Here, you getting Bitcoin is that culmination. So there is no other way Bitcoin is produced in Bitcoin network. And they want to keep, why they want to have that particular economic system in place, because there is no other regulatory body or there is no other regulatory governance. So they wanted to keep a currency which does not getting, it should be acting as a store of value. If you keep on printing an enormous amount of Bitcoin when there is no scarcity, right, the value of Bitcoin will not hold anything. It will become to the similar case like how USD has been printed in the last 2-3 years, and a lot of currencies are getting devalued against it. Or the inflation is rising itself also. It's kind of thing that currency is getting devalued. What the same currency you can get 2 years back, now for the same thing you need to pay more currency. So it is such a behavioral economics put in order to make sure that it is a self-regulatory thing. People are not able to take advantage of these constraints are put in, or these mathematical models are put in. And it is different for different blockchain. Every blockchain runs with different philosophy. It is, in recent past, it has become very much complex in Ethereum. Earlier, they used to have a very simple model, but as they are moving, actually they had a complex model in comparison to Bitcoin also. But now it has become more complex, where they start burning certain of the ether. Again, we will come back when we are going to do more hands-on and we are going to look Ethereum in detail. So for now, just consider there are two types of incentive a miner get. One, to mine a block. Another, to get all the mining fees, to get all the transaction fees from the transactions which are mined in the block. So in case a miner blocks even a zero block, means there is no transaction included in it, still he will get a mining fees. So in case no transaction is happening into the system, still in a Bitcoin network, block gets mined at scheduled time, because still he will require to solve the puzzle. Still he is putting in efforts to solve the puzzle to come up with a block which contains the solution. Any question here? I think again today we will not be able to complete the target what I had set. Yeah, still. Okay, so all these blockchain networks, right, or all the blockchain chain concept, firstly start with a block which is known as block 0, also known as a genesis block. So for any blockchain network to start, firstly it needs to have a genesis block. So what it should contain, because it's a very much important block, this is where any journey will start. Any blockchain journey, the first block journey will start. So in general, it does contain information about the ledger. You can write. So also these blocks contain a certain part which is just associated with data. You can write certain data there. So first block usually contain information about a ledger in an agreed upon data format. As we already talked about, right? Whatever, whether the transaction or the ledger, every data is a structured data structure which is already agreed within the protocol. You put information data block through hashing algorithm and get a hash code that is unique to those content. Resulting hash code becomes something of a name for that particular block or for a whole blockchain that follows. Also make easy to confirm that Genesis block content have never been changed. Anyone can recalculate the hash and will come out with the same as long as content are exactly same. So I think if you look into this particular theme, you will see a lot of where hash written, and we did cover certain overview of hash functions, what hashing is in our first lecture. If you all want me to just revise those concepts in 1 or 2 minutes, just let me know. Just let me know your intentions. We'll go through hash. We'll just immediately revise what hash was, what hash function is, and what hashing is. No need to go to hash. Okay. So just try to understand from a very layman perspective. There is a humongous amount of data. There is a bulk of data which is of infinite, not infinite length. It has a very infinite data set. You can create any length string and anything from that. You pass it through a function, and it always give you a unique value for your unique data set. So let's say you have written a bunch of data somewhere, and you pass through, you give input those data to a function, which is called a hash function. It will give you a output, which will be unique to your input. If you change just one minute things within your input, your output will change. Okay, so that is in general hash function is, but the output which you'll get, which will be a minified version. So the amount of number of strings here, or the byte code or the byte length, will be limited depending upon the protocol of your hash function. So currently a very standard hash functions which get used, or probably you would have used, is one is MD5 checksum, another is SHA-256 or SHA-250, SHA-128. So these are very standard hash function which get used. SHA-256, what it means? Whatever amount of data you provide, it will create a hash value which will be of 256 byte, right? And these hash functions are collision free. When we say collision free, what it means that for no two set of input, they are going to produce same output, and you can never take output and retrieve input from them. So let's say if you pass an input to a function, hash function, and you get an output, you give me an output, no way I can go and reproduce the input from the output which you have given me. I can never re-engineer it. You all can go and read hash function in detail. And in any case, when we are going to do an hands-on session, we will look into hash function in detail in any case. But if you all have free time, you can go and read about hash function properties. So very important properties which get used is collision free, one-way street, unique value created for each and every set of input. So what it means basically that all the blocks, correct, are identified by their hash signature. So when I say that we bunched those transactions, it means the transactions are taken in, their hashes are created, and hashes are stored. And similarly, when we are connecting it to the other block, the first block hash is calculated and put it as a payload into the next incoming block. Any doubt, any question here? And I will send you one thing which will give you an idea about how the genesis block of Bitcoin looked like. This is an article I have written. I have sent you in the chat window. Article I have written, I think 1.5 years back, 1 year back. It contains how the genesis blocks look like for Bitcoin. Let me also bring it up on the screen. So this is how hopefully you are able to see the screen, right? In any case, I have sent you the articles also on the chat. You can go in detail. But this is how the Bitcoin genesis block looked like. It had a link of an article which was about how the banks are getting bailed out again, how the economic system is collapsing and falling. And this was the very first genesis block, which was there put in by Satoshi Nakamoto with his own private key. And that's where the Bitcoin journey started. Any question, guys, here? Okay, so after the genesis block has been done, how the next block will look like. And similarly, the same replication will follow from there onwards. So the second block will contain the transactions which has been accepted, right? Then what will happen? It will also contain a certain linking from the block, the Genesis block, which was recorded previously, right? So what in general it takes the whole hash of block 0 or the Genesis block and also include in block 1 record. Now, what happens if, let's say, if somebody wants to fetch the data and let's say it continues. So now every block will contain the transaction sets plus an hash of a previous block. Hash of a previous block, what it contains? Hash of the previous block plus all the transaction को एक साथ combine करके उनका hash what has been taken out. So if you now and go change anything in this particular record set or data set has been recorded previously, your chain will get broken. Because the very beautiful thing about hash function is if you change even a single digit, even a minute thing in your input, your output will totally change. So if anything regarding to any transaction, anything regarding to last block linking, anything if change anywhere, immediately the chain will break, or immediately everybody will be able to know that this particular place somebody has done certain malicious thing. And nobody is going to accept those things within the network. By default, the protocol will start rejecting it. Anybody who has to change anything in the network will require to change from block 0 to the current block. Right? It is not possible to just change any historical block, which means any historical transaction which has been done in past, without changing the complete chain. Are you guys able to realize it? Are you guys able to get it what I'm trying to say? Any questions here? Okay, guys, then that's all for today. We will meet in the next session, and kindly make sure in the next session you are joining it via laptop or via desktop. Not on mobile phones. If you guys are currently joining via mobile phones or any handheld devices, please make sure to join in via a computer desktop. If it is Windows, it should have Linux subsystem enabled. Or in case it's a Linux based system, it is all fine. It is all good. We will require to use terminal a lot. So make sure that you have those things in place. Okay. Thanks everyone.